Okay, today's lesson is 3.4a of exponential and logarithmic equations. We are going to concentrate on exponential equations in this part A. So one of the things that we have to talk about is this one-to-one property with exponents and logs. So if you have two exponential expressions equal to each other, b to the x equals b to the y, if and only if x equals y. So if the bases are the same, the exponents have to be equal to each other. Likewise, I could start with the exponents and turn it into an exponential equation. Okay, similarly with logs, if I have the log base b of x equal to the log base b of y, if and only if x equals y. If the logs have the same bases, then the arguments, that's what we take the log of, have to be equal. Or if I start with xy, I can take the log of both sides of an equation if I need to solve. Okay? Now, I'm going to point out to you this. If it's not one-to-one, then we use the definition. And the main reason that I'm doing this is because this is the explanation you'll see in Delta Math. I have done it this way for years, but I've had way more success in the last couple of years when I've changed from concentrating on inverses. So the definition tells you that the log base b of x equals y if and only if b to the y is equal to x, which is what that says. There is no typo here. That says if and only if. That's how you write that in a shorter way. So again, I'm not going to use the definition. I prefer to concentrate on inverses because then you can use the same process for every equation. You don't have to remember, oh, do I do this or do I do that? Concentrate on inverses of each other. Okay, but the first thing we're going to do to solve exponential equations, we're going to look at these. 16 to the x plus 3 equals 4 to the 4x plus 7. When you have exponential equations, the absolute easiest way to do it is if you can write them both with a common base. So if you're not aware, okay, I showed this in class, but some people might have missed it, or if you weren't there on that day. On the day that I introduced logs, which was section 3.2, I put this chart on our calendar. So it's something to help you have all the powers there handy. It'll be handy when you do your Delta Math homework. You can use your calculator if you want. Okay, numbers are highlighted when they're the same to help you see that 64 could be 2 to the 6th, or it could be 4 to the 3rd, or it could be 8 squared. Okay, so in our first problem, we had 16 and 4. So, but I'm sure you already knew that, so I didn't really need to tell you. But I need to figure out how to write this equation with the same base. So I'm going to write 16 as 4 squared. Then I have to remember what my properties of exponents tell me, and that is if I raise a power to a power, what do I do to my exponents? Well, I multiply them. So 2 times the quantity of x plus 3 is 2x plus 6, and then I have 4x plus 7. That didn't change. But here we are, and we have two exponential expressions equal to each other, so I can, in essence, get rid of those bases and set the exponents equal to each other. 2x plus 6 equals 4x plus 7. If I subtract 2x, I'm going to have 2x on the right. Subtract 7, I'm going to have negative 1 on the left. And then I divide by 2, and that's going to give me x equal to negative 1/2. Okay? So now, look at 1b. 2/3 to the x minus 5 equals 9/4 to the 3x plus 4. And I'll give you a little clue. Okay, whenever you have a fraction and you have an exponent, you have to put parentheses around it. And I promise you, Delta Math will count it wrong if you don't, because it technically has to be there. So as I said to somebody recently, it's much better to use the parentheses. You could put parentheses over here. You don't have to have them because it's not a fraction, but it doesn't hurt. And so Delta Math won't count it wrong, but it will count it wrong if you don't put it on fractions. So looking at my bases, they're not the same. Bigger numbers on top over here, bigger numbers on the bottom here, bigger numbers on the top. So I'm going to flip one. It doesn't matter. I chose to flip this one. Okay. So when you flip a fraction, that means, okay, I'm actually going to change both of these setups. So when I flip a fraction, that means that it's raised to the negative 1 power. And now I just have to figure out how to write 9/4 as a power of 3/2. Well, 3 squared is 9 and 2 squared is 4. So that means this is 3/2 squared. Okay, now again, applying my properties of exponents. Okay, this would be, actually, I'll go ahead and write this down so you can see what I got here. I'm supposed to multiply these two things. So I could write negative x plus 5, which is also the same thing as 5 minus x. But I like to remember when you multiply by a negative, a subtraction problem by negative, it just switches the order. But it's the same thing. If you want to write negative x plus 5, it's fine. Okay, 2 times 3x over 4 becomes 3x over 2. Okay, and now I am back at the bases are the same. So I can set those exponents equal to each other. I'm going to multiply both sides by 2 to solve this. Then I'm going to add 2x, and then I'm going to divide by 5. So that's what we have. All right, on to the next example. So in our notes, the next example that was an exponential equation is number 4. So if you've got them all printed out, jump down to number 4. Okay, 4a, solve each equation round to the nearest hundredth. So I have 8 to the y equals 0.165. Well, clearly I cannot write these two things with the same base. So that means I'm going to figure out how to get rid of that to solve for y. So you can remember a couple of things. But what I like to do is what I'm saying I'm going to use inverses. This is an exponential equation here. And how do I undo that? I can undo it. Okay, I cannot write these with the common base, so I'm going to use the inverse. What is the inverse of the exponential? It is the logarithmic. So that means I can take the log of both sides, and I can use whatever base I want, but I'm going to use the base of my exponent, because when I do, then I'm going to have something that looks like this. I'm going to take the log base 8 of 8 to the y equals the log base 8 of 0.165. Okay, now why do I do that? We've talked about these are those White House problems that I talked about earlier. Log base 8 of 8 to the y is y. Where'd my y go? There it is. Couldn't find my y. And then I just have log base 8 of 0.165. Now you might go, well, I don't know how to do that. You've got your change of base rule, but really what I'm going to show you now is how easy it is to calculate this with ClassCalc if you don't have it on your calculator. So in ClassCalc, go to the scientific mode, and you have a log button, you have an LN button, and you have a log base B. So log base B means I can type whatever base I want. So I want base 8, and then it was 0.165. So my answer is negative 0.86648, goes on forever and ever. Okay, so back to here, y is equal to negative 0.8665. I'm supposed to round that to the nearest hundredth. 100 has 2 zeros, so that means I'm going 2 places, and that's going to be y equals negative 0.87. Okay, so I hope you'll remember that because that's really easy. Now you can always do that when you have ClassCalc. All right, looking at this next problem, it's not as straight up as this because I have an extra term here. So I need to move that term to the other side first. And when I take 8.48 and subtract 3.1, I'm going to get, what am I going to get? 5.38. So I now have 1.43 to the a equals 5.38. What is my base? Well, my base is 1.43a. So now I'm going to take the log base 1.43 of both sides. And when I know that my bases are the same. So these two, I'm composing inverse functions. So I have my answer of a is equal to the log base 1.43 of 5.38. Okay, we're going to put it in the calculator again. So I'm going to say the log base 1.43 arrow over of 5.38, and I get 4.70, so forth and so on. So a is equal to 4.7045 rounded to the nearest hundredth. That's my hundredths place, and it's going to be a is equal to 4.70. Okay, so straight up, look at C. C looks a little different because I now have a base of E. So you do have to know what is log base E. Well, log base E is what we more commonly write as ln. So I'm going to have the ln of e to the 2 plus 5w is equal to ln of 12, okay? And now when you see that, okay, it's just like those other ones, but this is what I often do, y'all. You might like this, is you get to go and get rid of that because they are inverses of each other, and the only thing I'm left with is 2 plus 5w equal to the ln of 12. And then I'm going to subtract 2, and then I'm going to divide by 5. And when I divide by 5, now I'm showing this to y'all because in Delta Math, it says give an exact answer. So if it says give an exact answer, then that's your answer. That's the exact value. If it says give a rounded, then you can put that in class calc just like that. Start off by hitting the divide button. Actually, I'll do that for you real quick. Let's see if we can do that. So I hit enter to get out of that one. If you hit divide first, then you can hit the ln button of 12. Got to get out of those parentheses, minus 2, and then come to the bottom and you type 5. So what you put into class calc looks exactly like what you put on your paper. That's what's so important about it. And when you do that, try to ignore the kitty. And that equals 0.09698. Rounded to the nearest hundredth is going to be 0.10. That is your rounded answer. So you got to pay attention, y'all, to the directions in Delta Math, especially if you miss it the first time. Look at the directions. So you might have supposed to be given an exact value versus a rounded answer, or you might have rounded to the wrong place. Okay, so what we just saw and what we just worked on, those were 3 examples where you had just one exponential expression and then you had a number. Okay, down here we have 2 exponentials. Okay, we have 2 exponentials and they're looking kind of messy. So when we do this, okay, sorry, cats everywhere here. I'm going to straight up, they're not the same base and I have more than one. So in that case, I always use ln. You can use log base 10 if you want to. It does not matter. I use ln because then I can always use ln. And if I have an e in my problem, I don't have to switch. So I'm going to take the ln of both sides. And when I do that on this next step, I'm going to use my power rule, and this is the exponent that's going to go in front of my expression. So it's going to look like that. And that is the way most of y'all will write it. And if you write it like that, you're going to mess up because you've got to remember that this whole thing is your exponent on both sides. That is going to change drastically how you move from here forward. So from here, I've got to distribute. ln of 6 is like a number, so I have to distribute that. So that's going to be 2x ln of x, 2x ln of 6 plus 4 ln 6 is equal to negative x ln 5 plus ln 5. Now, this is underlined because I have to get the x's on the both. I have to get x on the same side. So I'm going to take this expression with the x in it to the left side, and this expression over here to the right side. So I cannot combine these, y'all, in any way, shape, or form. So I'm just going to have 2x ln 6 plus x ln 5 equals ln 5 minus 4 ln 6. That's how we're moving things, okay? Because how do you get this to the other side as you add? How do you get that to the other side as you subtract, okay? Then this is the hard step for people to remember. I have an x in both of these terms that I have to factor out. So it looks like this. When you take an x out of here, I'm left with 2 ln 6. When you take the x out of this, I'm only left with ln 5. Nothing over here changed. Now, I'm trying to get the x by itself when I want to solve. So I'm going to divide by that expression. And when I do, I'm going to get x equal to ln 5 minus 4 ln 6. I'm dividing by that thing I just underlined, so that's going to be on the bottom. Okay? Again, this is the exact value. Okay? So you might have to enter this into Delta Math, so that's why it's important to know that, because sometimes he asks for it. But if you put it in your class calc, again, put the divided symbol first. you're going to get negative 1.0702, and you might practice before you do some delta math. The directions do say round to the nearest hundredth, which is where my 7 is. So this would become negative 1.07, and that would be the rounded answer. I knew that was going to happen. Try that again. Okay. Well, I missed it. That is, this guy is the rounded answer. Okay. 5b says 4 to the 3x plus 2 equals 6 to the 2x minus 1. So I'm doing the same thing. I'm going to have to take the log of both sides. And my exponent is going to get moved down front for both of these. So when you write them, okay, remember that you've got to have parentheses around the exponent. And now I'm going to distribute. So I'm going to have 3x ln 4 plus 2 ln 4 equals 2x ln 6 minus ln 6. Okay? I have to get my x's on the same side. It doesn't matter which side you collect it on, y'all. Okay? So I'm going to take this over to the left, which means that I'm going to subtract. So I'm going to have 3x ln 4 minus 2x ln 6. And then I got to get this to the other side, so I'm going to subtract it. So minus 2 ln 4 minus ln 6. Okay, same thing we just had. I have the x's on one side, but now I'm going to factor this x out. And when I factor it out, I've got 3 ln 4 minus 2 ln 6. So it's exactly what this says, just without the x because it's in front. And nothing on the right side changed. But I have to get rid of what's in the parentheses, so I'm going to divide, which means it's going to end up on the bottom when I write my final product, okay? So that, again, is your exact value. Put it into class calc, then you get negative 7.93. Rounded to the nearest hundredth, then I have going to have negative 7.93, and that is your rounded answer. So again, got to make sure you pay attention to those directions. Okay. Last problem. Solve exponential equations in quadratic form. Okay. So we've had something like this before. It was when we had things to the fourth power, and we did something called U substitution. Okay. But more importantly, how do you know when to use it in quadratic form? Well, when you're looking at this exponential equation, e to the 2x plus 2e to the x equals 8, okay? Whenever this exponent times 2 equals that exponent, you have a quadratic like, okay? So what I'm going to do is I'm going to let u equal e to the x, and you basically are choosing whatever that is, okay? The one that you had to multiply by 2 to get to the other one. So then when I square it, u squared equals e to the x squared, that simplifies to e to the 2x, which is what that is. So now I can write, instead of e to the 2x, I can write u squared. Instead of 2e to the x, I have 2u equals 8. It is a quadratic. I'm going to bring everything to one side, set it equal to 0. Then I'm going to factor, find the factors of 8 that subtract to give me 2, positive 2. And then I'm going to set each factor equal to 0. And I find out that u is equal to negative 4 or 2. But go back to your original problem. There is no u in it, so I'm not finished. I got to go back. And what does u equal? Well, u equals e to the x. So I'm going to have e to the x equals negative 4. And e to the x equals 2. Now, y'all, if you remember your exponential function, okay, it looks like this. It's no way that it can ever be a negative. So when you get that one, you get to ignore it. Okay? E to the x equals 2. Again, I'm at that exponential. How do I undo the exponential? I'm going to take the log of both sides. And I'm using ln because it's e. So ln of e to the x equals ln of 2. And this is where people enjoy doing this. Ln of e is, those are composing inverse functions, or it's color of the White House. So x equals ln of 2. And again, that's my exact answer. They didn't specify here. So you got to pay attention to delta math. If you were to put it into your calculator, that's your rounded answer. This is where's my exact value? There it is. Okay, we'll come back to that. So look at 6b, very, very last problem. 4e to the 4x plus 8e to the 2x equals 5. Again, if I take the exponent here, 2x, and I multiply it by 2, I get 4x. So that's how I know this is quadratic-like. This is what I want u to be. So I'm going to start off and let u equal e to the 2x, which means when I square both sides, I'm going to get e to the 4x. And now I'm going to write it. Now I'm only substituting the e part, so I'm going to have 4u squared plus 8u equals 5. Again, quadratic, got to set it equal to 0. And these, okay, 4 and 5 give you 20. I'm looking for the factors of 20 that subtract to give me 8. That's 10 and 2. So I'm going to make the inside and outside multiply to 10 and 2. Okay, this right here is 10, and that is 2. So positive 10, negative 2 give me positive 8. Okay, so I'm going to set each factor equal to 0. 2u plus 5 equals 0. Whoa, 2u minus 1 equals 0. Cat's feeling ignored. So u equals negative 5 halves, or u equals 1 half. What is u? U is e to the 2x. E to the 2x equals negative 5 halves, but it can't be negative. E to the 2x equals 1 half. How do I get rid of that e to the 2x? I'm going to use the inverse of it, which is the ln. So the ln of e to the 2x equals ln of 1 half. Again, I get to whoop and leave me with just 2x equals ln of 1 half. And then I'm going to divide by 2. So that is the exact value again. And you put that in Delta Math. I have done that. Oh, that's the next lesson. Okay. If you calls for a rounded answer, then you put that into class calc. And boom, that's exponential equations. If you have any questions or want to see it done a different way, please don't hesitate to contact us or email us. Thank you so much, and y'all have a great day.